Have you ever wondered why the sky is blue? It's a question that might have popped into your mind while lying on your back on a sunny day, staring up at the vast expanse of the azure sky. Some might say it's because the sky is reflecting the color of the ocean, while others might attribute it to the way our eyes perceive color. But the real answer is more intriguing and involves a phenomenon known as Rayleigh scattering. Rayleigh scattering, named after the British physicist Lord Rayleigh, is a process that causes light to scatter when it interacts with particles much smaller than the light's wavelength. This scattering of light is what gives the sky its characteristic blue color. But hold your horses, we're just scratching the surface of this captivating subject. Buckle up as we unravel the mystery of the blue sky and delve into the fascinating world of Rayleigh scattering. To understand why the sky is blue, we first need to comprehend the nature of light. Light, my dear friends, is a form of energy that doesn't just travel in straight lines but also in waves. It's like an invisible ocean in the air with waves of different lengths creating different colors. Now, when we think of sunlight, we often imagine it as pure white, but it's actually a cocktail of colors. Each of these colors has its own unique wavelength. Some colors, like red, have long wavelengths, while others, like blue, have shorter ones. When all these colors come together, the reds, the blues, the greens, and everything in between, they combine to form what our eyes perceive as white light. So when we contemplate the color of the sky, we're not just talking about some abstract painting, we're discussing sunlight and the fascinating way it interacts with our atmosphere. This brings us to Rayleigh scattering, the key player in our sky's color story. Named after the 19th century British physicist Lord Rayleigh, this phenomenon is the magic behind the azure curtain above us. Now imagine a sky full of tiny oxygen and nitrogen molecules. When the sunlight, a mixture of different colors, collides with these molecules, a process called scattering occurs. But here's the catch, not all colors are treated equally in this scattering party. You see, light travels in waves, and each color has its own unique wavelength. Red light has long, lazy waves, while blue and violet light travel in more energetic, shorter waves. As these short wavelength lights meet our sky's molecules, they are scattered in all directions, and voila! The sky becomes a canvas for these cool hues. But why blue, you might ask, when violet light also has a short wavelength? Well, it's a numbers game. There are simply more blue waves in sunlight than violet, and when you couple that with the fact that our atmosphere scatters short wavelength light in every direction, it's no wonder that blue gets the VIP treatment. But there's another twist to this tale. If our atmosphere gives the red carpet treatment to short wavelength light and violet waves are even shorter than blue, then why isn't our sky a vibrant shade of violet? Here's where it gets interesting. The sun emits less violet light to begin with, and what little it does emit is absorbed and then re-emitted by the ozone layer. So, even though violet light is technically scattered more, the sky doesn't appear violet to us. But if violet light is scattered more, why isn't the sky violet? That's where human perception comes into play. Our eyes are more sensitive to blue light and are better at picking up blue wavelengths than violet ones. This fact plays a crucial role in answering the question, why is the sky blue? You see, even though violet light gets scattered more by the atmosphere, our eyes are less sensitive to it and more sensitive to blue light. This means we perceive the sky as blue, not violet. Moreover, sunlight doesn't reach us evenly across the spectrum. It reaches us more at the blue part of the spectrum rather than the violet end. Thus, the sky appears blue, not because it is inherently so, but because of a fascinating dance involving sunlight, atmospheric particles, and our own human perception. So, next time you look up at the sky, you'll know that it's not just blue, but a fascinating interplay of sunlight, atmospheric particles, and human perception.